Hey everybody, and welcome to this week's class. Today, we're going to be learning about linear regression using scikit-learn. The problem that we're looking at. Lyft is a popular ride-sharing or ride-hailing company, as some people call it. Well, Lyft is trying to go public, and in gearing up for their IPO, potential investors are going to be focused on a number of key performance indicators, specifically sales and profitability. Well, Lyft is not going to be profitable anytime soon. So it's going to be really important for them to demonstrate their sales growth as well as a path to profitability. But for various reasons that we don't have time to get into today, sales per driver are going to be one of the most important KPIs. So with that said, our goal in this exercise is to predict Lyft's revenues per driver based on a data set that we have that includes both features and data related to Lyft's business. Now, the caveat here. While historical data and past sales are not always an indicator of future performance, if we hold all external factors constant for the purposes of this exercise, we should probably get pretty close to the ballpark. So how are we going to do this? Well, first off, we're going to set up a Jupyter notebook. Then we're going to import our data set from a MySQL database. Then we're going to do some exploratory data analysis, or EDA. Then we're going to randomly split our data set into two parts, one for training, one for testing. Then we're going to actually build our model. And as I mentioned in the beginning, we're going to be using linear regression models. Now, linear regression models are generally the go-to model that data scientists use to predict sales and to put forecasts together in general. We're going to use a fairly simple model known as a multivariate regression. So last, we'll be evaluating the model's performance, and you'll see all that in a few minutes. So let's head to our Jupyter notebook. Okay, so I'm going to go through the components of the Jupyter notebook and putting together the model very quickly, and then we can go back and do a deeper dive later on when we have more time, and also give you a chance to ask some of the high-level questions. All right, so let's hop to it. All right, so first off, we need to import the necessary libraries. You guys are probably familiar. As you've run a bunch of examples in the past, you need to have pandas and NumPy and the visualization packages of matplotlib and Seaborn. Next, we need to be able to import data into and put that into a data frame. For this project, we are pulling in data from a MySQL database, as I mentioned before, and we're using a really great package called SQL Alchemy, and what it does is actually it just creates a connector between the MySQL database and drops everything right into a data frame. And what's the coolest part about it is that you get to use straight SQL query language. Now, moving on to feature selection. The thing I would say about feature selection, this is where the modeling part gets interesting. You really need to be able to have some sort of domain or subject matter expertise if you're going to be answering business questions. So if we're going to be looking at what makes up Lyft's revenues, you need to know how Lyft calculates revenues, right? So in this particular case, we had to do some web research, which just pretty much consisted of going to Lyft's website and some ride-sharing blogs, and we learned that, and unsurprisingly so, that Lyft's fares are a function of both time and distance, right? So the duration and distance of a ride are how gross revenues are recorded. Now, from that, we need to understand, okay, so of that, how much does Lyft get to keep? And we know that in most cities it's about 20%. And we also saw that share goes as high as 25%. Okay, so now that we've done our web research and we know what types of features we're looking for, we could look back at our data set and say, okay, I need features that show both time elapsed and distance. Now, when we look back up at the database, we can see that a lot of these are timestamps. right? Timestamps, we can't model timestamps. What we can do though is subtract two timestamps in order to be able to get the actual number of minutes that elapsed between the two timestamps. And then if you take all of the rides that an individual driver gave and add up all of the minutes per each segment, then you're able to come up with a total duration of minutes, total duration of miles, the fees on top of it, and take that 20% off, and you're left with Lyft's cut. Pretty cool, right? All right, so now moving on to further exploratory data analysis. Now we need to check our features and make sure that that they look right. And a great way to do that is graphically. There's two different ways I'm going to show you here. One is through using a heat map, and you can see from the color bar here that we're definitely on the right track here with some fairly highly correlated features. Same thing here, since we're going to be using a linear regression. I thought it was kind of a cool idea to use it's called a pair plot that basically again takes two features and looks for correlation between the two. And as you can see from all the observations here, again we're on the right track. So moving further on to now we get a triangle model. So first we have to create our x variable, which is our x-axis, which contains all of our independent variables, and then our target variable on the y-axis. And that, again, the target variable is Lyft's cut. We need to then break apart our data set into a training and testing separate sets, which then we'll get into later. Then we need to build and train/fit our model. So this is where we pull from sklearn. They make it super easy. You just essentially create an instance of a linear regression model and add in your x variable and your y variables, and it fits it very quickly. Mileage will vary depending on how fast your machine is. Then we get the coefficients for each of the features. Then we make predictions, and one of the best ways to evaluate a model is to be able to look at the test data versus the predictions that we've made and plot them along. And if they're as close as they are in this line, you know that your model's probably pretty tight. That is essentially it in a nutshell. I'm going to open up to questions for now. Okay, our first question comes from Tyler Durden. Okay, Tyler asks, can you please clear up or clarify the relationship of the coefficient importance? Now, it's a really good question. Essentially, regression analysis is all about determining how changes in the independent variables are associated with changes in the dependent variable. Coefficients tell you about these changes. Our last question comes from Tom Riddle, and Tom asks, why is train test split so important? That's a really good question, Tom. The reason being is this: we want to avoid a term we haven't quite covered yet called model overfitting. And essentially, what you do when you train a model, you're to a data set. What you don't want it to do is to only be able to predict according to the exact observations that you see in one type of data set. You want it to be able to essentially learn and be able to predict to other data sets. And that's why you split the data sets. So the training allows it to do just that. And then the test part allows it to then try to predict on data that it's quote unquote never seen but hypothetically exists in the future. And that's the way you can actually cross-validate your data and make sure that you don't overfit your model. It's a good question.